Okay, this was my project. Presence of Batis villanor is an indicator for Sturnus vulgaris flock size. So the image on the left is Batis villanor. It's the pipevine swallowtail caterpillar, and the image on the right is Sturnus vulgaris. It's the European starling. Um, I had seen both these species in the nearby park, in a park near my house, and I wanted to see if the birds, the starlings, were eating the pipevine caterpillars. From an evolutionary standpoint, it would be smart to be near the food for the predators because they would be expending less energy in foraging, and they would therefore have more energy towards reproduction and probably have higher fitness. So my hypothesis was that more starlings would be in habitats with a greater density of caterpillars. And my prediction based on this hypothesis was that the p-value would be less than the alpha value, which would indicate a non-random correlation if I performed a correlation test on the data. So my methods were I went out in the park and I had to frighten the birds away initially, so I'd find some undergrowth because the starlings like to forage in undergrowth, and I would frighten the birds away and then count them as they flew away, and then stake put a stake at the spot where I thought the center of the flock was, and attached to that stake would be a 15-foot rope, which would basically be my radius for a 30-foot diameter circle, which would usually encapsulate the whole flock of where the whole flock of starlings was, and then I would scour the area of that circle for the caterpillars. I did not find a significant correlation between the variables. As you can see here, my R value was pretty close to 0, which I think indicates that there was not really a significant positive or negative correlation between the variables. My degrees of freedom were 6. I collected at 8 plots over 2 days, but one of the plots I think had the same number of caterpillars, so I think R interpreted it as 7 plots. My p-value exceeds the alpha value, so in this case we cannot reject the null hypothesis. So I learned after the fact that these pipevine caterpillars use aristolochic acid. Aristolochia are the plants, I think, pipevine that the caterpillars eat, and it allows them to survive their vulnerable juvenile stage. Because they're kind of conspicuous and would be easy pickings if they didn't have that toxin protecting them. And so the birds know not to eat them because of the warning coloration and their bad taste. Possible sources of error in this study were the sample size. I did my best to do quite a few plots, but the starlings were kind of hard to find, and so that could be a possible source of error. And then while they flew away, they were kind of difficult to count, but I did my best, and I could have missed caterpillars while I was searching for them. Also, what I had to consider afterwards was that maybe the starlings would be in locations with less caterpillars because they would eat them initially because they're easy to find. But then the no correlation between the number of caterpillars and the starlings kind of indicates that that's not really the case. One interesting thing to note here is that Roger Lederer is actually kind of a local ornithologist guy at Chico State. So I emailed him, and he said, yeah, it's unlikely that they're eating the caterpillars because of the bad taste that they'll get from the caterpillars. R code I used to do my analysis was in the tidyverse package. I had to bring in my Excel file for this. And then the attach function was very useful because it allowed me to just kind of access these variables. It was a nice one. I performed a correlation test. That's where I got my R value. And then I performed it was a linear model because both data points were quantitative, and that allowed me to get R squared, which was actually the adjusted R squared was negative in this case, which was kind of interesting, and the p-value and the degrees of freedom. And then I use the very useful ggplot function to plot data points, and you can see that plot in my lab report, along with R-squared and those other factors. So that concludes my presentation. Thank you.